Hello and welcome to another A-Level Maths revision video. Now for today's video here, what we're going to do then is take a look at some last minute revision for paper 3, right? Where paper 3 is the applied paper. So half of the paper is stats, half of the paper is mechanics. Now what I've done here then for today's video is chosen 8 questions that we're going to work through together. 4 of those questions are stats, 4 of those questions are mechanics. Now before we jump into today's video, and as you can see then we've already got question 1 on the screen here. There's just a couple of quick points that I do want to make right before we start with question 1 here. Now for the first point here then, this is in relation to the marks here for each question. So as you work through these questions with me here, you might think that the marks are slightly disproportional to what you would see here on your paper 3. And I would agree with that. And the reason for that is because these questions here, I have taken them from the old specifications. That's the old S1, M1, S2 and M2 papers. So the marks back in the day used to be a lot more generous. Unfortunately, that isn't the case for you guys. So apologies for that, but that isn't my choice. But yeah, just be aware of that as you work through the questions, right? It might look a little bit generous in terms of the marks. And like I said, that's just because they're taken from the old specification. Now for the second point here, this is in relation to the difficulty of the questions. So the question that we've chosen here for today's video. Now, I've tried to land somewhere in the middle here. I don't want the questions to be really, really easy. I also don't want the questions to be really, really difficult. I'd like them to be somewhere in the middle, just so it's kind of applicable to all students, really, right? So more than anything, the questions that I've chosen here are just testing the key skills and concepts here for stats and mechanics. If you are looking for something slightly more challenging, please do go and check out our predicted paper 3. We released that yesterday, and I'll put it somewhere in the top right corner here. If you want to go and view that, click the screen, or I'll leave a link in the description down below. So go and check that out. But like I said, there'll be a link somewhere here in the top right corner for that video. So other than that, I'm kind of just yapping here. Obviously, best of luck for paper 3 on Thursday. But other than that, that's everything I just wanted to quickly say here. So let's just get started then with question 1 here. So what have we got then here for question 1? So what I've got here is a sixth form college where we have year 12 and year 13 students, and they're either left-handed L or right-handed R. What we've then got here is a partially completed tree diagram where P is a probability, and this gives us information about these students here. So for the first part of this question here, then part A, all we want to do then is complete the tree diagram in terms of P where necessary. So I'll just make a note here then that this is for the tree diagram. So where do we begin here? Well, let's just start with this probability here, right? So if this probability here is P, this one here must be 1 minus this, right? So that's just going to simply be 1 minus P. And that's it, as easy as that. And the same applies here to the missing probabilities here, right? So this one is 1 minus this probability here. So 1 minus 1 over 8 is simply 7 over 8. And same again here, 1 minus 1 over 10, that gives us 9 over 10 there. Perfect, nice and easy, and that gives us the solution to part A. Now for the next part of this question here then, part B. What we're told here, so what I'm told then is the probability that a student is left-handed is 0.11. What we want to do here then is find the value of P. So we can easily do this then by using our tree diagram here, right? Our probability tree. So let me just quickly grab another color here. We'll do it in green, right? Seeing as we're working with a probability tree or a tree diagram, we'll keep it green. Seems in theme, right? Anyway, I'm kind of just yapping. So if we've got a student here, or the probability that a student here is left-handed, there's 2 ways that we can obtain that. They can be in year 12 and left-handed. That's one way to do it. The other way here is to be in year 13, and again, left-handed, right? So, going back to my original pen color here, in that case, I need to evaluate these 2 different products here. So P times 1 over 8 and 1 minus P times 1 over 10, and set those equal to 0.11, right? Because these 2 products here, when we add those together, that gives us the probability then that a student is left-handed. So, like we just said, then it's P times 1 over 8 plus So plus here, 1 minus p times 1 over 10. And like we just said then, this here is equal to 0.11. Perfect. So p times 1 over 8, right? That's just simply 1 over 8p, or p over 8, whichever way you prefer to write that. So 1 over 8p. Expanding this here then, so 1 times 1 over 10 is simply 1 over 10. I've then got minus p times 1 over 10, so I get minus 1 over 10p, or minus p over 10. Either's fine, whichever way you prefer to write that. Like so. And this here then is equal to 0.11. Perfect. Okay. So let's just simplify here then the left-hand side. So 1 over 8p minus 1 over 10p, that gives us 1 over 40p. To get 1 over 40p, what I'm also going to do here then at the same time is subtract 1 over 10 off both sides here, right? So 0.11 minus 0.1, that gives us 0.01 there. Okay. And then finally, to finish with here, you just want p, right? So I would just divide both sides by 1 over 40, or just times 3 by 40. They are equivalent. It really doesn't matter which way you do it. But either way, you'll get the same answer here of p is equal to 0.4. Okay. And there we have it then. So that gives us the solution there to part B. Now for the next part of this question, then part C, we want to find the probability that a student selected at random is in year 12 and also left-handed. So again, we go back to our probability tree here. So year 12 and left-handed. So we go up this branch here and we go down this branch here. And again, we're back to my original pen color here. That's going to be p times 1 over 8, where p is 0.4. So probability in year 12 and left-handed. So it's year 12 union L here. That is, it's going to be p, which is 0.4, times by this probability here of 1 over 8. And if we evaluate this here, what we get then is 0.05. Perfect. Good stuff there. Okay. And then finally, for the very last part of this question here, part D then, what does it say here? So what we're told here then, or what we're given, is that a student is right-handed. So if you're working for a question on probability and you see this phrase here, given that on a probability question, this also applies to a normal distribution question as well, where again, you're calculating probabilities, then what I've got here is conditional probability, right? So just always keep an eye out for that phrase there. If you see a given that on a probability question or a normal distribution question, and like I said, right, it does involve conditional probability. So we're given that a student is right-handed, and then for part D here, we want to find the probability that the student is in year 12. So what I'm looking for here is the probability that the student is in year 12, given that they're right-handed. So for conditional probability here, this would be equal to the probability then that they're in year 12. So the probability that they're in year 12 intersection R, because we're looking for the probability that they're in year 12 and right-handed. And what we do here then is we divide this then by the probability that they're right-handed. So for this probability here then within the numerator, we can easily deduce that by using our tree diagram. We'll do this one in red here. So year 12 and red. So we've got this branch here and up this branch here. So that's p times 7 over 8. We'll do that underneath here. So p, which is 0.4 times 7 over 8. And this here then is all over the probability that they're right-handed. So what is that probability? Well, don't worry about calculating this or anything like that. Just simply use the question as it's given to you. What we're told here is the probability that a student is left-handed is 0.11. So the probability that a student is right-handed is 1 minus this, right? So 1 minus 0.11. Bosh, perfect, nice and easy. At this point here, just put this into your calculator, right? And if you do this correctly here, what you should find then is we get 35 over 89. Okay. And there we have it then. So hopefully this first question here for starts wasn't too challenging. I know quite a few students do not enjoy probability. So hopefully a question like this does help then for tree diagrams. Tree diagrams doesn't come up every single year, but there's always a good chance that it could come up. So make sure that you're sharp here with tree diagrams and probability trees. So for the next question here, question 2, as we can see, then we've got these three forces, F1, F2, and F3. And these three forces then are acting on a particle P, and they're given as follows. So P and Q are just constants. But then given that the particle P is in equilibrium, and all we want to do here then, for the first part of this question anyway, is just find the value of P and the value of Q. So for part A then, what we've got here is these three forces acting on a particle P, but the particle P is in equilibrium. So what that means here then is F1 plus F2 plus F3 is equal to 0. So F1 plus F2 plus F3 is equal to 0, right? So all I simply need to do here is just add together the coefficients for the I component, set those equal to 0, and then just solve for P. And then we just do the same here with the coefficient for the J component, right? So -9 plus 6 plus Q is equal to 0. So let's just do that here then to begin with. So 7 plus 5 plus P is equal to 0 because the particle P is in equilibrium. So 7 plus 5 plus P is equal to 0. That would give me P plus 12 is equal to 0. And therefore then P here is equal to -12. And we're now just going to repeat this here then for the coefficient here of the J component. So we get -9 plus 6 plus Q is equal to 0. So we simplify this here then, what do we get? So we get Q minus 3 is equal to 0. And then finally here, Q is equal to 3. Perfect, good stuff. So that's the solution there to part A. Now for the next part of this question, then what we're told here is the force F3 is now removed. The resultant of F1 and F2 is given as R. What we want to do here then is find the magnitude of R. So for part B then, R here is equal to F1 plus F2. I should really be kind of doing the lines here underneath because these are vectors, but I'm just being a little bit lazy here, so just ignore that. But anyway, so R here is F1 plus F2. So what would that give us here then for R? So 7i plus 5i, I get 12i. So what I've got here is 12i. I've got -9j plus 6j, that's -3j. You get -3j there, like so. Don't forget the units here. This is a force, so newtons. But what we want here then is the magnitude of R. So the magnitude of R here is, don't forget, right, this is just simply an application of Pythagoras. So what I get here is the square root then of, so it's 12 squared. Oops, so 12 squared there, plus -3 squared. Plus -3 squared. If we simplify this here, what I get then is, I get 144 plus 9, which gives us the square root of 153 here. Like so. If you want to, you can give this as a decimal, but all I'm going to do here then is just keep this in its exact form, right? So you get the square root then of 153 newtons here, okay? And there we have it then. So that gives the solution there to part B. And then finally here for the very last part then, part C. What we want to find here then is the angle to the nearest degree that the direction of R makes with J here. So J being the unit vector, right? So what I would recommend doing here is just drawing a quick sketch. It doesn't need to be perfect, but all we want to do then is just visualize this problem, right? So the x-axis here would be I, right? My unit vector. So that's I there. And then for j here, that would be what would normally be my y-axis, right? So we get this here. Now, let's imagine that I continue this down here like so. What I want to do here then is just draw r, right? This resultant vector. So r is equal to f1 plus f2, but we've already evaluated that. It's 12i minus 3j. So we go 12 units along, down 3. It doesn't need to be perfect, but just something roughly, say here. Okay. So from the origin here to our vector, we get this. Okay. So this here is our vector, the resultant vector here, r. And what I'm looking for then is this angle here from j, our unit vector j here, all the way around. I want to know what this angle here is until we touch this vector, right? Well, I'm hoping it's kind of obvious. This angle here is just 90 degrees, right? And this angle here then, we can evaluate by using some basic trigonometry. So if I draw a triangle here, oops, it's not perfect, but you get the idea. I've got a right angle triangle. The base here would be 12 units, because we went 12 units along. The height here would be 3. We went 3 units down. So 3 units down there. And then this angle here is what we're looking to find, right? So what do we know here then? Well, I know that this side here is the opposite. That's the opposite there. This side here must be the adjacent. That's the adjacent, and clearly this is the hypotenuse, but we don't have anything for that, so I'll just leave it as it is. So in that case then, by basic trigonometry here, we've got the opposite, we've got the adjacent, so using tan here. Now if I call this angle then theta, if that's theta there, what I can see here then is tan theta. So tan theta is equal to the opposite over the adjacent. So 3 over 12 is just the same as 1 over 4. So tan theta is equal to 1 over 4. And therefore, in that case, then theta here is equal to tan inverse or arc tan, whichever you prefer, of 1 over 4. So 1 over 4. What that gives me here then, once I put this into my calculator here, and don't forget, right, we're working in degrees here as opposed to radians. What I get here then is 14.03. So 14.03 degrees there. Now, just be careful, right? This here isn't the angle to the nearest degree that the direction of r makes with j, because we had this part here, right? This 90 degrees as well. So therefore then, the angle that we want to find, so the angle is going to be 90 degrees plus 14.03 degrees. So to the nearest degree then, that would simply be 104 degrees there. Okay. And there we have it then. So hopefully nice and straightforward there for the first mechanics question for this video. So for the next question here, question 3, what we're given then is the discrete random variable x, which has the following probability distribution. So for the first part of this question here, then part A, it just says write down the name given to this distribution here. So just 1 mark for this. We just need literally 1 line of work in here. And it's just one of those definition type questions that you need to just remember. So what I've got here is 10 possible outcomes, right? 1, 2, 3, all the way through to 10. And each one of those probabilities then, or each one of those outcomes here, I should say, has a probability then of 1 over 10. So what I've got here then is a uniform distribution, right? Each outcome is equally likely. So for part A then, we have a uniform distribution. And that's what we need there then for part A, uniform distribution. So we then have part B here. So for part B then, it says write down the value of the following probabilities. So for B part 1 then, we have the probability then that x, our random variable x here, is equal to 10. So I'm hoping here that you can do this without drawing the actual probability distribution, right, the table. Because obviously we've got 10 possible outcomes here. it's going to be quite a long table. And the fact that each outcome here has the same probability makes calculating probabilities quite straightforward, right? Because the probability then that x is equal to 10 here, that would just simply be 1 over 10, right? 1 over 10 here, because if I just want 10 then, so little x here is equal to 10, then in that case, the probability that x equals 10 is just simply 1 over 10. I'm hoping that's quite obvious. I don't know if I've explained it very well, but hopefully I have. Anyway, B part 2 then. So for B part 2 here, this is the probability then that x is strictly less than 10. And again, I'm hoping here that this is straightforward enough that you don't need to draw the table. So if we're looking for the probability that x is strictly less than 10, then in this case here, what we want is 9, 8, 7, 6, 5, 4, 3, 2, and 1. We want everything but 10, right? So there's going to be 1 minus the probability that x is equal to 10, which, as we've just evaluated here, is 1 over 10. So we get 1 minus 1 over 10, which is equal to 9 over 10 there. Perfect. Hopefully, nice and easy. And now for the very last part then, part C here, what we're given here is a continuous random variable y, and that is following a normal distribution, right? So for part C here, what I've got then is y here, which follows a normal distribution with the following parameters. So the mean is 10, and we have a variance then of 2 squared. So again, all we want to find here then is a couple of probabilities. So again, I'm hoping this is quite straightforward. For C part 1, so for C part 1 here, just be very, very careful. So for the probability that y is equal to 10 here, a really common mistake then is for students to grab the calculator, start inputting this into NPD and getting a probability. But that isn't how we do this, right? For the normal distribution, don't forget the normal distribution is a continuous distribution, right? We've got a continuous random variable. So if it follows the normal distribution, it's a continuous distribution. Then in that case here, the probability that our random variable y here is equal to an exact value, that's always 0, right? Continuous distribution cannot be equal to an exact value. So the probability that y is equal to 10 is just simply 0, okay? So nice and straightforward there then for C part 1. And then for C part 2 here, what have we got here then? So this is the probability then that y is strictly less than 10. So for this one here, just grab your calculator. In fact, you don't even need a calculator, right? If the random variable y here has this normal distribution, where the mean is 10, and we're looking for the probability that y is strictly less than 10, then if you think about that as a bell curve, we'll get something. Okay, that is not a good drawing. It should obviously be symmetrical. So if I try again, by the way, my art skills are shocking. It's not perfect. It should be a little further along. So if I quickly just draw it further along, I don't know how well I'm explaining this. That's a bit better. So if this here is the mean, so mu is equal to 10, then the probability that y is straight less than 10 is just half of this, right? It's symmetrical about the mean. So in that case, then the probability that y is straight less than 10 is 0.5. If you want to, you can just use a calculator as well. That's absolutely fine. So it would be stats mode, distribution, normal, and then NCD. So in this case here, because we're looking for the probability that y is straight less than 10, my lower value then is minus 99999, just an arbitrarily small value. The upper value here, I put 10. For sigma then, that's the square root of 2 squared, so it's just 2. And then for the mean here, that is 10. Input that, and yeah, you simply get 0.5. But if you just recognize the fact that it's symmetrical about the mean, then it's just simply going to be 0.5. Either's fine, but you might just save a little bit more time just recognizing this here. Okay, so there we have it then. Hopefully nice and straightforward there. That gives us the solution then to question 3. So for the next question here, question 4, I'm going to start with a fun fact here that this question is 19 years old And it's probably older than most of you sit in the paper on Thursday. Just a fun little fact there, right? Completely unrelated to your exam, but I thought you might find it interesting. Anyway, what have we got here? So for part A then. Let's just read the question first, right? It's always a good starting point. So what I can see here then is figure 1. And figure 1 shows the speed time graph of a cyclist moving on a straight road over a 7-second period. The sections of the graph from t equals 0 to t equals 3 and from t equals 3 to t equals 7 are straight lines. The section from t equals 3 to t equals 7 is parallel to the t-axis here, as we can see right on figure 1. So for part A then, or for this question here, it just says state what can be deduced about the motion of the cyclist from the fact that, and as we can see here, we've got 3 different parts to this question. So to be honest here, this is quite a nice, easy question. If you get something this easy on your exam, we're absolutely cooking. And slightly diabolical is the fact that this part C here is 4 marks. If you were to get 4 marks for this on your A-level maths paper, that would be slightly ridiculous. But anyway, I digress. Part A then. So the graph from t equals 0 to t equals 3 is a straight line. So that's this straight line here. What does that tell us here then? So what this tells us here, as we can see, right, it's just traveling with constant acceleration. That's all you simply need to be able to deduce here. So it's traveling with constant acceleration. Why do we know that's the case here? Well, the gradient here won't change, right? It's just a straight line. So the gradient here remains constant. And because the gradient remains constant, then what that tells me here is the acceleration is constant. So all we say then is it's traveling with constant acceleration. So we simply need there 1 mark in the bag. Now for part B then, what can we deduce then about the motion of the cyclist from the fact that the graph from t equals 3 to t equals 7 is parallel to the t-axis? So what that tells me here then is we are traveling with constant speed. We are traveling here with constant speed. So traveling with constant speed here. Obviously the gradient here of this line would be 0. So in that case then we just have constant speed. Okay, so hopefully just one of those things that you do recognize here. Same again for part A, right? That we're traveling with constant acceleration. And then finally here, for part C, all we want to do here then is find the distance traveled by the cyclist during this 7-second period. So a slightly more challenging aspect to this question, but for 4 marks, this is slightly ridiculous. But anyway, we'll answer it. So how do we find the distance here traveled by the cyclist during this 7-second period? Well, the easiest way to do this, and let me just do this in a different pen here. So just get rid of that so I don't cause any confusion. Is what I want to do then is find the area under the graph, right? The area under this speed time graph would give us the distance traveled in the 7-second period, right? From 0 to 7. So what I'm going to do here is break this up into 2 separate shapes. What I've got then is this trapezium here, which I'll do in dark red. And then I'll do the square here. Well, rectangle, I think it is, in blue. Okay. So yeah, it's a rectangle rather than a square. Slightly embarrassing, but anyway, ignore that. So going back to my original pen color here. What we'll do then is just find the 2 separate areas, right? So for the area of the trapezium here, should be nice and straightforward. So this height here, my parallel height is this height is 2. This height here is 5. So we add those together, divide by 2, and then we times here by the base, which is 3. So trapezium, I'll do it in the same color here, just so it kind of matches up and it's consistent. So for the trapezium here, it's simply, like we just said, then a half times 2 plus 5, and then we times by 3. So what does that give us here? 7 over 2 times 3, that's 21 over 2, right? And then for the rectangle here, So for the rectangle here, my base is 4, my height is 5, so 4 times by 5 there is 20. Perfect. And then finally, to find the distance traveled here by the cyclist during the 7-second period, all we do here then is just add these two separate areas together. So let's just make a note here then. So therefore the distance traveled is, so it's 21 over 2 plus 20. 21 over 2 plus 20. That would be 21 over 2 plus 40 over 2. So I get 61 over 2. So we're working in meters here. Let's just quickly check the graph. Yeah, v meters per second, right? So 61 over 2 meters there. Perfect. You can also just write this as 30.5. That's also fine. Either way. 61 over 2 or 30.5, either's fine. And there we have it then. So, like you can see, quite a straightforward question. You're definitely not going to get 4 marks here for something like that in part C. That would be extremely generous. But like you can see, you used to hand these marks out like candy on the old specification. Unfortunately, not quite the case. But yeah, there we have it, right? So that's the solution there to question 4. So for the next question here, question 5, we have a question on the normal distribution. So what we've got here then is the heights of adult females that are normally distributed with a mean of 160 centimeters and a standard deviation of 8 centimeters. Now for the first part of this question, then part A, all we want to do here then is just find the probability that a randomly selected adult female has a height greater than 170 centimeters. Now to get us started here then, what we need to do is just define a random variable to model this situation, right? Now given that we're talking about height here, I'm just going to choose h as my random variable, but it's completely up to you. You can choose x, y, z. It really doesn't matter, okay? So I choose h here as my random variable, and h then will follow a normal distribution with a mean of 160. So a mean of 160 and a standard deviation then of, so my standard deviation here is 8 centimeters. So my variance then is 8 squared, right? Bosh, good stuff. Now, for part A then, what I'm looking for here is the probability, let's do this underneath here, the probability then that our random variable h here is greater than 170, okay? And to find this probability here then, what we're going to do is just use our calculator, right? So I grab my calculator here, I go into stats mode. What I want here then is distribution. So I make a little list here. So distribution, obviously we're working with a normal distribution here, so I press norm. So norm there. Now just a quick point here, when you're working with the normal distribution, we never work with NPD here. Don't forget then that the normal distribution is a continuous distribution, so we don't want NPD. In this case here, what we want then is NCD, okay? So I press NCD there. And then what it wants here is a few different things. So the data type here is clearly a variable, right? We have a random variable as opposed to a list. It then wants the lower and upper value here. Let me just write these down here. So lower and upper. Now just be careful here then. I always say that I think it works in a slightly counterintuitive way to what you might expect. So, because what I want here is the probability that h is greater than 170. 170 is my lower value here, not the upper. Okay, so the lower value is 170. Or the upper value here, what I do then is I just pick an arbitrarily large value. So to satisfy that, I just put a load of 9s. Something like that is absolutely fine. For sigma then, well, that's just given to us in the question, right? The standard deviation, that's 8. So sigma is 8. And then for mu here, mu is simply, again, given in the question as 160. That's the mean there. Perfect. We input all of those, press enter. And what I get here then is this probability. Now, if you've done this correctly then, what we should find here is we get 0.1056 there. Perfect. Okay. So that gives us the solution there to part A. Now for the next part of this question here, then what are we told? So what we're told here is any adult female whose height is greater than 170 centimeters is defined as tall. An adult female is chosen at random and given that she is tall. So straight away here, I see this phrase then, given that, and in either a probability question or a question for the normal distribution, if you see given that, we're working here with conditional probability. Let's just make a note here then, conditional probability. Okay, so for part B then, what we want to do here is find the probability then that she has a height greater than 180 centimeters. Right, so for part B then, conditional probability here. So what we're looking for here then in part B is the probability that H is greater than 180, as we're told here. So H is greater than 180, given that she is tall. And for this part of the question here, we define tall as being greater than 170 centimeters. So H is greater than 170, right? Bosh. Now, what I'm going to do here is use the formula then for conditional probability. So what I get here is, so I'm going to get the probability then that H is greater than 170 and H, so intersection H here, is greater than 180. And this then is all over the probability then that H is greater than 170. Now for the numerator here, we can easily simplify this, right? Because if we want both H being greater than 170 and H being greater than 180, well clearly then H being greater than 180 satisfies both of those. So we can rewrite this here then as the probability that H is greater than 180 all over the probability then that H is greater than 170. Okay? Now, we already know this probability here, right? We established that or deduced that in part A. That's 0.1056. So all we need to do here then is just evaluate this probability here within the numerator. And again, to do this, all we need to do here is just use our calculator. And pretty much everything is the exact same here, other than the lower value. All I need to do here then is just change that to 180, right? If I quickly do that, what I get here then is, so I get 0.0062097, so on and so on. So what I've got here is, like we just said then, 0.0062 all over the probability that H is greater than 170, which, as we deduced in part A, is 0.1056, right? 0.1056 there. Just input this fraction here then into your calculator. And if you do this correctly then, what you should get here is 0.0. We get 0.0587 there. Okay. And there we have it then. So like is the solution there to part B. And then finally, for the very last part of this question here, we have part C. So what we're told here. So what we're told then is half of tall adult females have a height greater than H centimeters. What we want to do here then is find the value of H. So again, we're using conditional probability here. So for part C then, what I'm looking for here is the probability then that H is greater than little h here, like so. And this then is conditioned on being tall, right? So H is greater than 170. Because here what we're looking at then is half of the tall adult female. So because it's half then, this probability here is equal to 0.5. Okay? And again, all I'm going to do here is use the formula then for conditional probability. So again, the same applies here. If we're looking for some value then, H here, well, this must be clearly greater than 170. So my numerator here will just be the probability that H is greater than little h. Similar to what we did here then. I hope that makes sense. Hopefully I've explained that clearly. Maybe not, but it doesn't matter anyway. You'll see here in a moment. And again, that will be over the probability that H is greater than 170. So putting that all together then, what I get here is, so we get the probability then that H here is greater than little h. This is all over the probability then that H is greater than 170. And this here then is equal to 0.5, right? like so. So this here is just a simplification of the conditional probability formula, this formula here, okay? Now, we know this probability here, again, we deduce that in part A, that's 0.1056. So what I've got here is, so I've got the probability then that H is greater than little h. That's all over 0.1056, 0.1056, and this here then is equal to 0.5, right? So let's just multiply both sides of this equation here by 0.1056. So if I do that here then, what I get is the probability that h is greater than little h is equal to get 0.0, so 0.0528 there. Okay. Now, how do we evaluate little h here? So what I'm going to do then is go into stats mode again. And what we need to do here is use the inverse normal distribution function on our calculator, right? So again, I'll make a little list here. Let me just kind of box this off then. So this was for part C here. So again, distribution. Again, we're working with the normal distribution here, so that doesn't change. So norm. And then what I want here is inverse normal. So that's inv n there. On my calculator anyway, it might look slightly different, but inverse normal here is what we want. Okay. And again, it wants a few different things here. So we've got the data type. So in this case here, again, that doesn't change. It's just a variable. Now for the tail here, that is just whichever way the inequality is pointing. So because this is greater than, it's pointing to the right. I know that's a very, very elementary and basic way to think about this, but I think that's the most easiest way to think about it. So for the tail here, that is right. Like that. For the area here, that is this probability here then. So 0.0528. Okay. For sigma and mu here, that doesn't change. And now for sigma and mu here, again, that doesn't change, right? So sigma here is 8. And for mu here, that is 160. Okay. Input all of that. What we get here then is 172.946324. So if we round this here then to say 3 significant figures, what we get here then for h is that h is equal to 173 there. Okay. And we're talking about height here. So h centimeters, so 173 centimeters there. Perfect. Nicely done. So like you can see, not the easiest normal distribution question here, but hopefully an example here of using the inverse normal distribution function on your calculator might illuminate how we can answer questions such as that one, right? Like you can see, it's just simply calculator skills and just understanding then which way, you know, the probabilities kind of work here and how that kind of correlates to the calculator. Okay, so it is an important skill that you can use your calculator. I do think many students kind of take that for granted. So please make sure then that you are confident with using your calculator to find probabilities then for the binomial. And as we've just seen here, the normal distribution. Okay. But there we have it then. So that is the solution here to question 5. Now for the next question here, question 6, as we can see then we've got figure 2 here. Now what do we have for this question then? So we've got a box of mass 2 kilograms that's pulled up a rough plane by means of a light rope. The plane is inclined at an angle of 20 degrees to the horizontal, but we can see that in figure 2, right? And the rope is parallel to a line of greatest slope of the plane. The tension in the rope is 18 newtons. So again, we can see that in figure 2, right? What we're also told here is the coefficient of friction between the box and the plane is 0.6. And by modeling the box as a particle, we want to find the following things here. So to get us started here then, we have part A. So we've got a diagram here. So what we need to do then is just add the relevant forces here to our diagram, right? If you don't have a diagram at the start of the question, which is sometimes the case, they won't always give you a diagram, draw your own diagram and then add the relevant forces, right? Please don't try and do these questions without a diagram. That is asking for trouble. So I'll do this in a different color here. Let's do it in, we'll do it in green here. So what forces can we add to our diagram here? So I've got the weight force here. That acts vertically downwards, right? Like so. So the mass here is 2 kg. So that's 2g. Like so. What else can we add here? Now, this force, right? The weight force, we do need to split that into components. So something like that and something like that. My diagram is very small, so it's not the easiest to see, but hopefully you can just about follow along here. Now, this angle here will be the same as this angle here, the angle of inclination. So that's 20 degrees. So this component here, that will be 2g cos 20 degrees. And then for this component here, so this is my horizontal component, this is 2g sine 20 degrees. Okay, I'm hoping that's kind of obvious. Let's draw a slightly bigger version of it here, so it's a little bit easier to see. This is 2g, and then split it into components here. Obviously, it's a right angle triangle. This is 20 degrees. This here is my 2g cos 20 degrees. And this here is my 2g sine 20 degrees. Okay, so hopefully here, a bigger version of that does help a little bit. What else can we add here then to the diagram? Well, we've got the normal reaction here. I'll do that in orange. So the normal reaction of the plane on the box, right, which is what we want to find for pi anyway. So I'll label that as R there. That's the normal reaction of the plane on the box. We've also got friction here. I'll do friction in a different color. So the box is being pulled up the plane, so friction opposes motion, so friction will act down the plane here. So friction will act down the plane here. I'm just going to label that as F here. We do know the coefficient of friction, but I'll just leave it now as F here. We can, sort that later on in the question. And then, are we missing anything else here? Just the acceleration, right? So we do that in a different color as well. We'll do it in light blue here. So the acceleration here being pulled up the plane, so it's accelerating up the plane, right? So something like that. Perfect. I think that's everything that we need here. So let's find the normal reaction of the plane on the box here. So part A then, what I'm going to do here is resolve perpendicular to the plane, right? So resolving perpendicular to the plane here, taking up as positive then. What would I get here? So what forces do we have acting up here, perpendicular to the plane? I've got R here. So I've got R. There's no more forces acting up the plane here. Acting perpendicular to the plane. So that's fine. Now what forces are acting down here, perpendicular to the plane? That would just simply be this force here, 2g cos 20. And that's acting in the opposite direction here to what I've took as positive. So that's negative, right? So I get R minus then 2g cos 20 degrees. Okay? Now, normally here, we would use Newton's second law, right? So F equals ma. But in the perpendicular direction here, there's no motion. So A is equal to 0. And in that case, then ma is simply 0. So R minus 2g cos 20 degrees is equal to 0. And in that case, we just want R here, right? Just add 2g cos 20 degrees to both sides. So therefore, R here is equal to 2g cos 20 degrees. And at this point here, just put this into your calculator, right? So that's 2 times 9.8 cos 20 degrees. Put it into your calculator. And we should find here then two free significant figures is we get 18.4 newtons there. Perfect. So this here then is a normal reaction of the plane on the box. That gives us the solution there to part A. Now for the second part of this question, then part B, what do we want to do here? So we want to find the acceleration of the box. So to do that here, what I'm going to do then is resolve parallel to the plane, and I'm going to take up here as positive, given that the the particle or the plane here. The particle or the box here is being pulled up the plane. Okay, so resolve parallel to the plane here, taken up as positive. So what forces do we have acting up the plane here? So I've got 18, this force here, like so. There's no more forces acting up the plane here, parallel to the plane anyway. So that's fine. Now what forces are acting down the plane here, parallel to the plane? I've got this force here of 2g sine 20 degrees. So I've got 18 minus 2g sine 20 degrees. And they're acting in the opposite direction here. So they're going down the plane, so we take those as negative. And also here, don't forget then that we also have friction. So friction here is mu r, where mu is 0.6, right? So minus then 0.6 r here, okay? And this here then is equal to ma. Now we do have acceleration here in this case in the parallel sense. We didn't for the perpendicular direction here, but for the parallel direction, then yes, we do, because it's, accelerating up the plane. So the mass here is 2 kg. So I get 2 times a to get 2a there. Okay. So what I've got here then is 18 minus 2g sine 20 degrees. We can just put that into our calculator. And I've then got 0.6 times r here. But don't forget r, we just evaluate that in part A, right? So r here is 18.4. So for the left-hand side here, just put all of this into your calculator. And what you should find here then is we get 2a is equal to 0.256, so on and so on. Okay. But don't forget then, we just want to find a here. So simply all I need to do here then is just divide both sides by 2, right? And therefore in that case then a here is equal to 0.256, so on and so on, divided by 2 into 3 significant figures here then. What I get is 0.123 there. Okay. And of course, don't forget the units here, right? This is acceleration. So we're going to get meters per second squared here. So ms to the minus 2 there. Okay. And there we have it then. So hopefully my explanation did help there. And hopefully you can kind of see what's going on here with the diagram. If you're not too sure, use a slightly bigger version of, the force that's split into components. I do think sometimes that can help. Trying to fit it onto the diagrams here isn't always the easiest. You don't get a ton of room. But yeah, hopefully that's helped. Okay. So there we have it then. That gives us the solution here to question 6. Now for the penultimate question here, question 7, what do we have then? So what we've got here is a teacher who records the number of hours students are revising for their upcoming maths exam by using their online learning system. The teacher chooses the first 50 names that appear on the online learning system to form their sample. And as we can see, then the results here are presented in this table. So for the first part of this question, then part A, all we want to do here is just name the sampling method that the teacher has used. So hopefully you just recognize straight away then that if the teacher chooses the first 50 names that appear on the list, this is just simply opportunity or convenience sampling, whichever you prefer to call it. They are just the same thing. You don't have to give both, by the way. Just one of those is absolutely fine. So opportunity. So opportunity / convenience sampling. Convenience sampling there. Okay. And there we have it then. So hopefully nice and straightforward there for part A. Now for part B then, what does it ask us to do here? So it just says then, briefly explain with a reason whether the hours spent revising H is a continuous or discrete variable. So in this case here, H is a continuous variable. So H is a continuous variable. Continuous. There we go. I can't spell very well. So H is a continuous variable. And why is that the case? Well, H here is a measurement of time, and time is a continuous variable, right? Because we can pick 2 points and then choose somewhere in between that, right? So h is a continuous variable as time is a continuous variable. Okay. And something along those lines is absolutely fine. Again, it's just 1 mark. It doesn't need to be a novel or anything like that. There we go. Okay, so there we have it then. That is the solution to part B. So for the next part of this question, then part C, what do we want to do here? So for part C then, it just says give 2 reasons why a histogram could be used to model the data. Right, so for part C then, given that it wants us to give 2 reasons, what I'll do here is I'll present these as 2 separate bullet points. So for the first bullet point here, if we're going to use a histogram then, I think the first most obvious point here is that time, or h here, the hour spent revising, is a continuous variable, right? As we deduced here in part B. So time / h here is a continuous variable. So continuous variable. There we go. That's all we need there for the first bullet point, right? And then for the second bullet point here, all I'm going to say then is the data here is in a grouped frequency table, right? As we can see by this table. Again, I'm hoping this is kind of obvious. So let's just say here that the data, is in a grouped frequency table. Okay. And there we have it then. Again, it's just 2 marks, right? 2 marks for 2 points. It doesn't need to be extensive in terms of what you put. These 2 points here are absolutely fine. And now finally then, for the very last part of this question here, part D, it just says then, use your calculator to find estimates for the mean and standard deviation of the hours spent revising. Right, so all we're going to do here is just simply use our calculator, right? So we don't need loads of work in here or anything like that, but you do need to know how to use the calculator then to find estimates here for the mean and standard deviation of a grouped frequency table. Now, some of you won't know how to do this, right? So a question like this is good practice. So obviously, it should go without saying here, you do need a calculator. It would be impressive to do this without a calculator when it asks you to use a calculator. So grab your calculator, right? Let's not overcomplicate this. So I go into stats mode here. Now, clearly, the first thing that I need here is the midpoints of my class boundaries. So this would be 3 here. This would be 7.5. This here would be 12.5. This here would be 17.5. And then finally, this here would be 22.5. Okay, so these values here are the midpoints then for our class boundaries. So midpoints. Okay, so these here are my midpoints. I kind of just box these off here as I go. Something like that is absolutely fine. So what I do here, as we said before, is we go into stats mode. And when you go into stats mode, we get list 1, list 2, list 3, list 4, so on and so on, right? And what I need here is 2 lists. So I'm going to use list 1. So list 1 and also list 2 here. Okay. Now in list 1 then, what I'm going to do here is input the midpoints here. So I've got 3, 7.5, 12.5. We've got 17.5. And then finally here, 22.5. Okay. So list 1 then, as we said before, is for the midpoints. And then what do we put in list 2 here? So in list 2 then, what I input here is the frequencies. And please do make sure that these match up respectively here. So for the midpoint of 3, that frequency should be 9. For the midpoint of 7.5, that frequency should be 14, so on and so on. So I get 9, 14, 20, 5, and 2 here. Okay. So we've inputted the data here. What do we do next? So what I press here is calc. So I press calc here. Now I get a choice of 4 things here. I get 1 var, 2 var, reg, and I also get set here. So set is kind of like the options here, or settings. And this will allow me to find then an estimate for the mean and standard deviation of a grouped frequency table. So let's go into settings here, because more than likely your default settings here are not correct. So I press settings and I get a few different options again here. So on my calculator anyway, what I get here is 1 var X list, 1 var frequency, 2 var X list, 2 var Y list, and then 2 var frequency. So ignore all the 2 var stuff. That's for 2 variables. We're not concerned about that. All I'm concerned about here is 1 var X list and 1 var frequency. So for can't speak here. We'll try again. So for 1 var X list, what I want here is list 1. So let me just write this down here. So for 1 var X list here, what we input here then is list 1. So list 1 there. And then for 1 var frequency here, for 1 var frequency, what I input here is list 2. List 2. Like I said before, ignore all the 2 var stuff. That's just fine. Leave it as it is. Come back then to stats mode here. So again, we get a choice of 1 var, 2 var, and reg for regression. So we're not concerned about regression. What we are concerned about here is 1 var, 1 variable here. So to finish with then, all you need to do here is just press 1 var. I press 1 var here. And once I do that, what I get here is some summary statistics, right? I get X bar, the sample mean. We get sigma X squared. We also get sigma X being the standard deviation. We get N, the sample size. We get Q1, the lower quartile. We get the median. We get Q3, the upper quartile. So on and so on, right? So what we want here for this question is the mean and standard deviation. So the mean then, that is X bar. So all we need to do here then is just read it from our calculator, right? So X bar here is 10.29. And then for the standard deviation here, just be very, very careful here. So on your calculator, you'll get 2 standard deviations given. You'll get sigma X, like that, and you'll also get SX. The one that we want here is sigma X, okay? Just be very, very careful for that. This is the one we want here, okay? So we want this. So to finish with here then, sigma X, in this case, it would technically be sigma H, given that the variable that we're working with here is H. Doesn't really matter too much, but sigma here, let's give it as sigma, is going to be, what do we get here? And that would also be H bar. I just kind of realized that I've gone through the working. It doesn't really matter. You get the mark anyway. So sigma here is, if you've done this correctly anyway, 2 3 significant figures here, we get 4.99 there. Okay. And that's 2 3 significant figures. Okay. And there we have it then. So hopefully this demonstration here for how to use your calculator to find estimates for the mean and standard deviation of a grouped frequency table has been helpful, right? So hopefully, maybe, fingers crossed, we might get a question on Thursday based on this here, right? So fingers crossed for that. But anyway, there we have it. So that is the solution here to question 7. And then finally, to finish with here, we now have the very last question, question 8. So as we can see then, as we do with most mechanics questions here, right, we have a particle P. So the particle P then has a mass of 0.5 kg. And this moves under the action of a single force, F newtons. Now, at time t seconds, the velocity v meters per second of the particle P is given as follows. So what we want to find here then is the following 2 things. Right, so for part A then, what we want here is the acceleration of P at time t seconds. So what I've got here is the velocity, but we want the acceleration. So as I always do here, SVA. So what we've got here is the velocity vector, we want the acceleration vector. So we're going down here. So don't forget then, if we're going down here, we differentiate with respect to time t. So d by dt. If it was going the other way here, just a quick point then. So if it was going the other way here, then we would be integrating with respect to time t. So that would be the integral then of dt there. Okay, but like we said before then, got the velocity vector here. We now want the acceleration here, the acceleration vector. So all we need to do here then is just differentiate v with respect to time t. Should hopefully be pretty straightforward. So for the acceleration here, this is the acceleration vector. What do we get here then? So just go term by term, right? So the 3t squared here, that just differentiates to give us 6t. So what I get here then is 6ti, like so. For the 1 minus 4t here, so the 1, that's a constant. So don't forget that when you differentiate a constant, it's just 0. The minus 4t here, that differentiates to give us minus 4. So what I get here then is 6ti minus 4j there. Okay. And there we have it. So straightforward as that. So this here is the acceleration of p at time t seconds. Okay, so there we have it then. The first 2 marks, nice and easy. And now for the final part of this question here then, part B, what we want to do here is find the magnitude of f when t is equal to 2. So the question is structured in such a way that the previous part of the question here, part A, will help us to answer part B. So what we're going to use here, so here we're going to use Newton's second law, right? F is equal to ma, okay? So the mass of the particle here is 0.5 kg. So F is equal to a half A. So A here is what we obtained in part A, quite appropriately. So what I'm going to get here then, or what would I get here then, I should say. So F is equal to half of this, so half of 6ti minus 4j. So that is, so I get 3ti, so 3ti there, minus 2j. Okay, so this here then is for the force. I should be writing this as a vector as well. I'm just being a little bit lazy here. But there we go. So what we want to know here is the magnitude of F when t is equal to 2. So the first thing I need to do here then is substitute t equals 2 into this equation here for force, right? So when t equals 2, what do we get here then? So what I get here is the force F is equal to, so 3 times 2 is 6, so I get 6i. So 6i minus 2j, right? That's just constant, we can't do anything with that. So minus 2j, like so. And then finally here, we want the magnitude then, what we simply need to do here is just use Pythagoras, right? So let's just do this underneath here. So the magnitude then of F here is equal to, so like we just said, it's just simply Pythagoras here. So we have the square root then of, so what have I got here? That's going to be 6 squared. I get 6 squared there. Close the brackets. Plus minus 2 squared. Plus minus 2 squared. Like so. 6 squared here. That is 36. Minus 2 squared is 4. So what I get here then is root 40. So we get root 40. You could just leave the answer as this. What I will do is just give it in its simplest form. So root 40, we can write that as root 4 root 10. So that's 2 root 10. Like so. If you want to, you can give this as a decimal. That's also fine. But where possible, it is nice to just keep things in their exact form, right? And there we have it. If you want to, you can also give the units here. So it'd be in newtons as well. But it doesn't really matter too much for the magnitude here. Okay? And there we have it then. So hopefully the solution there to question 8 wasn't too bad. Like we said then, this here is the very last question for this last minute revision video. So to finish with here then, all I want to say is best of luck with paper 3 on Thursday. As always, thank you so much for watching. I do appreciate each and every single one of you that does watch these videos. And yeah, I think that's everything from me. So best of luck and thank you for watching.